if we talk about machine, what is a machine? Can somebody give me a definition? What is a machine doing from the simplest one to the most complex one?
Anything that helps human, Pak. Human works.
Okay, it helps human, that's the purpose. But what is inside it, right? I mean, what is it composed of? And the inside of, I mean, how do you define the content of a machine? What is it doing? Think of the most common ones you find is the engine in a car. What does an engine do?
Basically, turns one kind of energy into another kind of energy.
Okay, so
Apply force, Pak.
kenapa?
Apply force.
Apply force. Okay, so it's producing some kind of power, right? Energy, producing some kind of energy, but energy cannot be created, right? So energy comes from something else, but it's doing a conversion, right? It's essentially converting all the different kinds of energy. And if you think about chemical energy, fossil fuel, right? Gasoline or electricity, battery is chemical energy, right? Waktu kalian nyimpen listrik di dalam baterai, what are you doing? You are converting from electricity, electrical energy to chemical energy, right? Karena dipisahin di dua elektroda ini kan. Kalian memisahkan ion. And then waktu kalian connect baterainya, the ion starts flowing and it's back to electrical. But as a battery, it's chemical energy. So machines does all this conversion, right? Electrical to chemical, chemical to electrical. Waktu kalian nge-charge handphone kalian, you're converting electrical to chemical. Waktu kalian pakai handphone, chemical to electrical, to light, right? Display itu kan light. Light is energy. TV jadi light and information, right? Kinetic, of course. Machines, engines do kinetic motion. Motion linear or rotational. Most of them are rotation. That's why we will study about shaft. Okay, heat. It's sometimes desired, sometimes it's not desired. Kalau mesin kalian adalah heater, tentu saja is desired. Kalau mesin kalian mobil, it's undesired. Karena buat apa panasnya? Kan dibuang doang. In fact, make a guess of the typical efficiency of a car engine. What is the conversion efficiency in percentage? Anybody want to make a guess?
Like from fuel to
the
I don't know, like 13, 10, 20 to 1. I don't know.
30% kayaknya.
Yang lain, ada yang mau make a guess? In comparison, electric motors are about 90% efficient. What about gasoline engines? Take a shot, yang lain. Nobody wants to make a guess?
About 70, sir.
Okay, ada yang bilang 70, ada yang bilang 13 or 15.
No,
Yang lain?
like 15 to 1, like the fuel to like energy ratio maybe.
Oh, okay.
30, Pak.
30. Ada yang lagi googling mungkin. So it's yeah, I mean it ranges from 20 to 35%, I would say. Yeah. 40% is already very efficient. Karena believe it or not, fossil fuel, gasoline content, energy content is a lot. It's a lot in a fuel actually. Makanya sebenarnya fossil fuel itu kurang efficient because it's very hard to convert that efficiently. But there is a lot of energy content. I mean, why do you think all the oil companies are so rich, right? Because you are getting a lot of energy from that. A lot of it goes into what? If it's only 30% efficient, yang masuk dan keluar menjadi energi gerak, sisanya kemana?
Heat and noise.
Ya, a lot of it is heat. Ya, masnya bayangin aja engine kalian panasnya seberapa panas. All that is wasted. It goes into nothing, just heating up the atmosphere, right? So machines are not always efficient, but some of them are efficient. Right, you have combustion engines, electrical machines, even spring watches yang gerak di tangan kalian gerak, right? You're converting different mechanical energy into another mechanical energy, right? Battery chargers are machines, essentially, if it's we think about energy conversion. So most actuators, right, generates motion, kinetic, from fuel or electricity, right? Either electric motors atau gasoline engines into kinetic. And the heat is sometimes wanted, sometimes unwanted. What kind of machines where you do want the heat? In what kind of machines do you desire heat?
Induction heater, Pak.
Heaters, of course. If you are dealing with heaters, then you want the heat. So not in too many cases though. I mean, if you have boilers, then you want heat. But other than that, heat is usually unwanted. Now there are generators which convert in the opposite direction, right? From kinetic or heat to electricity. Those are also machines. But let's talk about cars. Let's consider what are the different components atau systems in a car. Nah, saya mau kita brainstorm ini bersama-sama. Where's my ink space? Coba. Why can't I? Okay. So if you think about a car, sorry, not the best artistic guy here. Okay. If you think about a car, you want to build a car from scratch and you're not an automobile engineer. Try to think about what you would need, which then brings you the systems that you need in the car. The first thing is very easy, right? I mean, what do you need?
Engine.
Engine, right? So you have engine. Okay, so you have an engine here that drives the wheels, right? Now, between the engine and the wheel, you need some kind of connections.
The axle.
You need axles, right?
Transmission, Pak.
Engine kan keluarnya cuma di ujungnya pulley atau shaft, gitu kan? So the connection is called a transmission.
Transmission.
Transmission, yeah.
Its job is to transmit, right? Transmit power. So you have connections from the engine through a gearbox. If it's rear-wheel drive, then you have a shaft going to the back. Okay? So engine and transmission. Now, okay, think about you're designing a car. you're in the 1910, in the same generation as Henry Ford, right? You're trying to design a car. What else would you need?
Setir Pak, setir.
Ya,
Wheel.
perlu setir tentu saja kan. Oke. So you need steering. Karena kan harus dikendalikan kan. Oke, apa lagi? You need steering. The steering link to the front wheels and there is some mechanism, right?
You need the braking
Of course
system.
you need to stop. Yeah. Brakes. So you have the brake systems. Okay, now I think at this point we kind of have the most basic thing that you have to have, but it's not nice, right? Nobody will buy this kind of car.
Bangku, Pak.
Okay, interiors. Interiors.
Wheel, Pak. Wheel.
Uh,
Roda, Pak.
Okay, roda udah di sana. Tapi what do you need?
Suspension.
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 Okay. What is the purpose of a suspension? There
Biar
are
Biar empuk Pak, biar empuk.
nggak gatel.
there are three purposes of a suspension.
Biar nggak keras Pak.
To
Okay, comfort,
absorb shock and balance.
absorb shock is comfort, but balance. What do you mean by balance?
Like what I studied for the E46, they make the suspension system from German, and then they create it so it's balanced. So like doesn't go like
Jadi
everywhere.
maksudnya waktu dia cornering gitu ya?
Yeah, like the weight distribution is balanced.
Okay. That is handling, right? Because it turns out that steering and suspension have a lot of interaction to each other, right? They are very much connected. Karena waktu kalian belok, the weight shift, right? The weight shift, and it affects how your tire is connected to the ground. What is the other purpose here we're missing? This other purpose is something that most people don't realize why they need a suspension. Of course, you need comfort. Of course, you need to handle
Sambungan Pak, sambungan.
sambungan.
Itu control arm.
Kerangka roda bukan ya?
Itu yang tadi transmission ya. Transmission ini udah including axles. Ya.
Oke Pak.
Control
Biar
arm.
nggak cepat rusak, Pak.
Biar nggak cepet rusak. Okay. If you get comfort, then the rest of the components will also be kind of comforted, right? And so it reduces vibration. That's kind of include here, right? Reduce vibration or impact. One more. Coba kalian bayangkan kalau kalian nggak ada suspension. Jadi artinya box kalian, cabin, duduk di atas roda keras, ya. Langsung connectionnya langsung duduk di situ. Kalau kalian sambil ngegas, lalu kalian lewat jalan rusak, selain tidak comfortable, apa yang terjadi dengan connection antara your wheels and the ground?
Banting,
Oh, itu traction. Itu nggak termasuk handling apa?
Enggak, handling itu lebih weight shift. Jadi lebih weight shift dan lain sebagainya. So traction has to do with the connection to the ground. Okay? And traction is something that is the job of a suspension. So when you have bumps, kalian pernah lihat nggak kalau mobil lagi, terutama mobil bagus ya, kalau lewatin bumps, what happens to the wheel and the chassis? Chassis-nya diem, rodanya yang naik.
Iya. Ada gap, Pak.
So the job of the suspension, one of the most important job actually, is to trace the road. Oke? Okay? Jadi rodanya itu naik turun, ngikutin the profile of the road. Jadi kalau rodanya naik turun, kalau jalannya naik turun, rodanya tetap melekat. Ya kan? Melekat ya, dalam tanda kutip. Dia tetap nempel ke aspal, dan dia bisa accelerate. Jadi kalau analogi yang tadi saya bilang, begitu kalian masuk jalan rusak, tapi tidak ada suspension, kalian bakal ngambang-ngambang. Oke? Okay? Jadi it's gonna float, right? And the wheels will spin in the air. So getting the wheels to the ground at all times is the job of the suspension, which is very critical. Okay, apalagi? What other systems do we need?
The safety system, sir.
Safety, okay. How do you achieve safety?
Airbag, sir.
Seatbelt, airbags.
Okay. Safety systems. Airbags, ini, dan of course brakes. Brakes. Brakes only work as good as your tires. Ini satu hal yang orang suka belum mengerti ya. If you have a Ferrari brakes, even if you have big brakes, orang-orang upgrade kan pakai Brembo, wah disknya segede gini. What good is it if your tire doesn't stick to the ground? Right? It's gonna skid. Dia bakal ngunci wheelsnya dan sliding aja. So you cannot stop unless your tire is good. In fact, believe it or not, you don't need to upgrade your brakes. You need to upgrade your tires before you upgrade your brakes. Jadi buat kalian yang suka upgrade ke big brakes, Brembo dan kawan-kawan, it's useless unless your tire is as good. In fact, you might need to upgrade to a wider tires if you want your brakes to be good. Yeah, because the bottleneck is not on your brakes. Most cars, if you slam on the brake, you can lock the wheels. Ya nggak? Even kalian beli mobil paling cupu, Ayla atau Agya, kalau kalian slam on the brake, wheels kalian pasti lock up dan dia ngesot kan? Most of.
Kan ada ABS, sir.
Hah?
Kan ada ABS.
ABS system.
Oh iya. ABS is part of the safety system ya. Tapi I'm talking about the brakes, strictly the brakes, right? Karena ABS itu basically take over your brakes sehingga kalian tidak lock up the wheels. But in a traditional brake, I mean, if you slam on the brake, you're gonna skid. And so, where is the bottleneck? It's not the brakes, it's the tires, right? It's the friction between the tires and the ground. Okay, now kalian kan anak mechatronics nih. You guys have not mentioned one subsystem that is very, very crucial.
Fuel,
The brain,
Pedal gas.
Elektronik.
Ecu.
Oh yeah, ECU, engine control unit, right? So tadi sampai mana? Engine control units. Nah ini baru engine ya. Kalau kalian automatic transmission, ada juga transmission control unit. right? Lalu ada accessories, all the electricals, right? Engine electricals, all the sensors is as crucial. Hari gini kalau sensor kalian broken, the engine simply doesn't work. Kalau masih karburator dan semuanya mechanical, pakai platina, then you don't need any electronics and it will run. In fact, motor-motor zaman saya SMA nggak pakai aki pun masih bisa jalan, ya kan? Tapi not these days. Okay, electrical is also accessories electrical. Tadi kan ada interiors ya, interiors, accessories, right? Okay, so I think we covered most of it, and then you have all the power windows, right? Itu maksudnya accessories ya. Suspension, brakes, engine, you have cooling, right? Inside the engine, it's kind of a subsystem of the engine, right? You have the cooling systems. And accessories including AC, right? You have the AC system. Siapa di sini bisa drive tanpa AC? In fact, waktu saya pasang turbo di Honda Integra saya, some people demi making extra power, mereka copot AC-nya. Not me. I need my AC, man. Definitely. Apalagi di Indo. Okay, so let's cover some of these, and what I would like to talk about is the performance and design factors in each of these subsystems. Okay, so let's take a break. I usually take a one-time break instead of 2 times, yeah, and just finish earlier. Okay, so let's take a 10-minute break. Be back. Okay, let's resume. Turn on your cameras again. Okay, we were... Okay. We were discussing a little bit about car subsystems, right? Now that we brainstorm pretty much the bulk or the major components, let's go through each one of them, and I would like to introduce you about design, yeah, because the title of this course is machine design, right? Machine design. So we're here to design machine elements or components, right? When you say you design something, now I know this is a lecture actually for semester 5 about design. What is design? But whenever you try to design something, you have an objective and you have factors and decisions to make, right? Let's say you design a car, right? You gotta pick the engine size, for example. Okay, you gotta pick. You gotta make a decision on the engine size. How would you make that decision? How would you decide whether the engine is a single cylinder 100 cc like the Honda Honda Beat? Ya kan 100 berapa sih? 115 ya. And then how do you decide between 100 cc all the way to like 5 liters engine 5000 cc? I mean, how do you make the decision?
The size of the engine bay, for example.
Tapi kan size of the engine bay bisa follow the engine. Kalau engine-nya lebih gede ya saya bikin bay-nya lebih gede dong. Kan we're designing from scratch here.
The
Sesuai
purpose of
kebutuhan.
the car.
Maybe you can classify.
Do function, sir.
Okay. You guys are mentioning important keywords there, right? Function, purpose, kebutuhan, right? That's the objective. So let's say we're making, so now you're starting to put some constraints atau pagar gitu kan. Okay, we're transporting 4 people, for example. If you're transporting 4 people, then you need 4 seats. So you are already defining some space. And that space tentu aja harus dibungkus metal cabin. And so a metal cabin that can accommodate 4 people, beratnya itu udah kira-kira 500 kg. The cabin itself, empty, nothing on it, right? Nah, untuk transport a cabin 500 kilograms, let's say, with 4 people, I need some kind of acceleration, ya dong? Nah, sekarang acceleration sendiri kan kita mau seberapa kenceng nih? 0 sampai 100 km per jam. Are you making a car for grandma? Or are you making a car for you know, a teenager yang trying to prove you know, his self-worth with his acceleration? Right? It depends on your market. And so you're putting design factors yang lalu influence the decision. But what you need to keep in mind is that any decision you make has a trade-off, right? Sebenarnya kan, okay, even though I'm making car for grandma, tapi kan saya bisa aja taruh engine yang 5 liter, like a Mustang or Corvette. Nggak apa-apa kan? Tinggal dia gasnya kecil-kecil aja kan? Tapi trade-off-nya apa kalau saya bikin engine-nya besar? What do you sacrifice?
A fuel consumption.
Efficiency, right? Your grandma is going to complain about the fuel efficiency and she's not going to buy your car. So you have fuel efficiency, you have power and performance. Not to mention the cost of the car itself, right? Kalau kalian bikin engine lebih besar, harga mobilnya juga pasti lebih tinggi. So and then comes, you know, all kind of trade factors juga. Misalnya, do you want the performance in low RPM atau high RPM? Engine characteristics-nya gimana? Jadi every time you talk about design, you talk about performance, right? Performance dalam hal apa yang penting? Lalu apa yang kita korbankan untuk mencapai performance itu? Nah, ini sedikit philosophical, but I want you to understand that every time you design or you come up with something, a design solution, tidak ada desain yang sempurna, karena kamu pasti sacrifice sesuatu. Entah itu harga, entah itu fitur, demi something else yang menurut kamu lebih penting. Misalnya yang penting murah. Kita lagi desain, you know, transmission buat Avanza. Ya, kita nggak perlu the most powerful transmission. Kita perlunya apa? Efficiency. Karena kalian menjual ke orang yang beli Avanza. Gitu kan? Kalian nggak mau bikin compression ratio terlalu tinggi. Nanti harus isinya Pertamax. Kalau kalian mau bikin engine yang bisa pakai premium pun jalan reliably, gitu kan? So that's what I want to talk about in each one of these components, right? The engine block, right? Transmission, valve train, intake, exhaust, ignition, and so these are the sub components of an engine, right? And so we talk about engine size, we talk about design factors for the engine, okay? But many of you maybe don't know how an engine works. So let's watch a video on that, okay? With animation. All right, how car engine works. Suaranya nongol nggak ya? Tunggu. Presentation audio is on. Okay.
A car engine generates power from the expansion of compressed air in a contained cylinder with the help of fuel. That is why
Putus-putus ya.
Agak kasak-kasak
Ya
juga,
Pak, putus-putus Pak.
It's reloading now. Hold on.
Grammarly does more than catch errors. With Grammarly, you
Okay, hold on. I think I gotta change my display. It's a bit too heavy for my computer. Okay, is everything still on? Okay, hold on.
A car engine generates power from the expansion of compressed air in a contained cylinder with the help of fuel. That is why it's called as an internal combustion engine. Before getting into the working, let's see the main parts involved in the working of an engine. First, the crankshaft. This is the part which converts the linear motion of the piston to a rotational force. Next, the pistons and the piston rods. The pistons will be pushed down by the expansion of compressed air, and turns the crankshaft. And the valves, which controls the flow of air and fuel into the cylinders. These valves are driven by the intake camshaft, and the exhaust camshaft, and the camshafts are driven by the crank itself, using a timing belt. There will be idler pulleys, and a tensioner pulley, to hold the belt tight in place. This here is the internal structure of a 4-stroke, inline 4-cylinder, DOHC engine, which is commonly found in most hatchback and sedan cars. A 4-stroke engine should pass through 4 different strokes, to complete one cycle to produce power. They are intake, compression, power, and exhaust stroke. The crank to camshaft ratio is 2:1, which means it will take 2 crank revolutions to complete 1 camshaft revolution. And the camshafts are designed in a responsive manner, to open or close based on the corresponding strokes of each cylinder. Let's take a look at a single cylinder, and see how a 4-stroke engine works in detail. In order to ignite the air-fuel mixture, a spark plug is used. This will ignite the compressed air-fuel mixture, with the help of an electrical spark. We will take it down by each stroke. The intake stroke. The inlet valve opens and the downward movement of the piston creates a suction. This pulls the air-fuel mixture into the cylinder. Once the air-fuel mixture is in the cylinder, compression stroke begins compressing the mixture. At this time both inlet and outlet valves stays closed. At the end of compression stroke, the air-fuel mixture is ignited by the spark plug. The explosion exerts pressure and pushes the piston down. This is the power stroke which produces power to the crank. At the exhaust stroke, the outlet valves opens and the piston pushes out the burned gas. The cycle starts again from intake stroke, keeping the engine running and produces power. For a carburetor engine, the air and fuel are mixed inside the carburetor assembly, and fed to the cylinders. In the case of a fuel-injected engine, the fuel is injected into the intake manifold, or directly into the cylinders. Since only a power stroke produces power, you may wonder how the engine turns continuously. Well, the answer is in the crank itself. The flywheel and the crank counterweights provides momentum, which keeps the crankshaft from stopping immediately. For a 4-cylinder engine, considering any time instance, one cylinder is always in power stroke, which produces more power and less vibrations comparing to a single-cylinder engine. And that is how a car engine produces power in simple. Thanks for watching, and stay tuned for more presentations from Auto.
Oke, tadi suaranya keluar kan ya?
Keluar, Pak.
Keluar, Pak.
So, yeah, I don't have time to explain everything, but what I would like to highlight in this first week of course is, we're gonna learn each component of typical machines, right? In this case, the example is a gasoline engine, but parts that are common, there are shafts. Kebanyakan machines itu the power is a rotational power, just because it's practical, right? I mean, think about if you want a machine to produce a linear power, kan nggak bisa continuous ya, maksudnya dorong terus udah dong mentok, right? So I mean it's just necessary by practicality for any machine to produce motion power, it will be rotation. Ya kan? Karena kalau rotation kan bisa muter terus kan. Kalau linear jalan mentok terus apa? Terus mesinnya stop gitu. Kan it's just impractical. So in many cases it's rotational power. So you have rotation, and then you can convert this rotation into translation using transmission and rack and pinion and all those kind of gearing. Nah, di atas ini juga ada valves untuk masuk dan keluar. Okay, you got springs. We will learn about springs. We will learn about axles, flywheels maybe. You got belts connecting the crankshaft to the camshaft di atas ini. Okay, the camshaft itu control the valve opening. They gotta be synchronized. This belt is called a timing belt. Okay, they synchronize the rotation of the crankshaft and the camshaft. We will learn about belts. And in many cars now, they use timing chain instead of timing belts. Timing belts has to be replaced like 90,000 miles, or no, 70,000 miles, about 100,000 kilometers, I would say. You have to change timing belts. Timing chain doesn't need replacement. Kalau timing belt kalian putus, ini valve atas bisa kebentok sama piston bawah in an interference engine. So waktu valve-nya turun, pistonnya naik dan dia nabrak karena dia maju mundurnya tidak synchronized. And so your engine is done at the time. Itu siap-siap spend like puluhan juta. Okay, these ignitions are timed using a controller. You got all the combustion, but that's not machine elements. Okay, so next we have a transmission to connect the engine to the wheels. Okay. So I'm sharing a different video here. Let's watch this one. Maybe I'll stop it in the middle if we need to. Tab kalian yang saya share sekarang transmission systems kan ya? Confirm?
Belum keluar, Pak.
Belum, Pak.
Ya? That's weird. Oke, udah nongol.
Udah Pak.
Uploading.
Oke.
Udah, Pak.
Okay, this one doesn't have an explanation, so I'll just mute the presentation audio and I'll just explain it. So when you want to connect your engine to the axles of your wheels, you have to have not just the connections, but also some manipulation between the speed and the torque. Okay, so you have torque and speed relationships. We'll talk more about this when we get to transmissions, right? So you connect the crankshaft to the flywheel and this clutch. Now the clutch, we will study clutch also. The clutch enables you to separate between the engine and the transmission. See, the problem with engines, combustion engines, is that it has to keep rotating. Begitu dia stop, dia mati, and then you harus di starter lagi kan. And so when you're what happens when you're stopping at the traffic light? You got to disconnect the engine from the wheels because the wheels stop, right? You're stopping, your car is stopping, but the engine may not stop. So you have to have a method to disconnect between the engine and the rest of the transmission. So you press the clutch and it separates it. Okay, that's what the clutch is. In automatic transmission, it's connected using what is called a torque converter. Now that one is a bit more complex, but it's basically a fluid coupling. Ya, torque converter is a fluid coupling. Jadi kalau yang satunya stop, yang satunya tetap muter, itu nggak apa-apa. It's not a mechanical joining of the clutch. Okay. Now the transmission, all these gears, is the one responsible to manipulate the torque and RPM. If you remember in your bicycle, right, the mountain bike, most of you would probably have a mountain bike. Kalian bisa oper giginya kan? Pindah-pindah chainnya, sprocketnya. Kalau kalian pilih sprocket yang kecil di depan, yang besar di belakang, enteng kan? Jadi kalau enteng, you generate a lot of torque. Kalau misalnya depannya gede, belakangnya kecil, berat. Artinya torque yang nyampe ke belakang kecil, tapi kalian dapat speed. So depending on whether you need a lot of torque or you need a lot of speed, that's what the transmission does. It does the manipulation. Okay? In the first gear, you get a lot of torque, but not too much speed. In a higher gear, like the fifth gear, you get not too much torque because you're just overcoming the wind, right? In the highway, you're just overcoming wind resistance. You're not really accelerating much. Then you go into fifth gear. Makanya kan accelerationnya berat ya. Kalau udah fifth gear, kalian injak atau udah top gear lah kalau di automatic transmission, kalian injek gasnya kan udah susah ya. Udah susah accelerate ya. Karena you sacrifice torque for the sake of speed. Okay, so we're kind of multitasking here. So this is how you select the different gears. Now, in the real transmission, it's a bit different. I think that's enough for transmission. So let's go to steering. Nggak bisa langsung ganti ya. Okay. Okay. Okay, I'll skip some of these.
This means that for perfect steering, the left and right wheels should turn at different angles. The steering mechanism is used to carry out this purpose. The most commonly used steering mechanism in modern vehicles is the rack and pinion type. Let's see how this mechanism manages to steer the vehicle. A rack is at the center of this mechanism. This rack is constrained so that it can only move in a straight line. The pinion, which comes from the steering, can make this rack move. A part called a steering arm is attached to both of the wheels. This part is constrained so it only has a rotational motion along the axis shown. The steering arm is connected to the car frame via a roller bearing. This makes sure that it can only turn. A tie rod connects the steering arm to the rack. The tie rod can have both translational and rotational motion. Now, just observe what happens to the wheels when the rack moves. You can see that the left and right wheels are turning at different angles. If you track the meeting point of the left and right wheels, you can see the meeting point always lies on the rear wheel line. Thus, the rack and pinion mechanism perfectly satisfies the conditions needed for steering. Due to this, the vehicle makes a turn without slipping.
This mechanism is called the Ackermann steering geometry. Okay? The Ackermann steering geometry makes sure that the left wheel and the right wheel angle is not the same. In fact, they converge on that common point, which also intersect with your rear wheel, and therefore it creates a smooth radius when you turn. Okay? So the geometry is such that it will do that. It's called the Ackermann steering geometry.
The steering we have discussed so far was the manual type. Nowadays, electric motor-assisted power steering is widely used on most cars. Electric power steering makes the steering action effortless and more accurate. A column-assisted power steering unit is shown here. Here, a brushless DC motor drives the steering column and the pinion. The motor is capable of rotating in both clockwise and anti-clockwise directions. An electronic control unit decides the amount of power the motor should transfer to the column. The ECU takes the following inputs, such as the torque the driver has applied to the steering wheel, the steering angle, the steering wheel speed, and the vehicle speed, and then decides the appropriate torque to be supplied. A Hall effect-based sensor and torsion bar arrangement is used to measure the driver's torque input. Due to the motor's power assistance, the steering wheel rotation becomes effortless for the driver. Do you think this is a perfect mechanism? Wait for a moment and think about what happens to this steering in the case of a motor failing. You might be aware of the fact that a worm screw can turn a worm gear, but a worm gear cannot turn a worm screw. This means that if the motor fails, any manual rotation by the driver will be blocked by this constraint of the worm drive. In short, the steering becomes jammed. To overcome this issue, the rotation from the steering wheel is never directly connected to the worm gear. Instead, it passes through a planetary gear set. Here, the driver's rotation is given to the sun gear. The output is drawn from the carrier, and the worm gear also becomes ring gear of the planetary gear set. During normal operation, power from the ring gear will be easily transferred to the carrier. In case of motor failure, the ring gear cannot move. However, you can see the driver's manual rotation of the sun gear will be transferred to the carrier and finally to the pinion gear.
Oke, ada yang tanya? Barusan ada yang raise hand. This is an electric power steering. Now, in the old days, it's hydraulic power steering. Nowadays, it's getting more and more common for hydraulic power steering, electric power steering. Just because of the controls technology that we have now, right? You got the torque sensor. Jadi dia cuma kasih kamu assist sesuai dengan effort kamu, right? It becomes a a closed loop feedback yang selalu on, right? Waktu kamu putting more effort, dia langsung bantu lebih, tapi tidak berlebihan. Kan nggak boleh dong dia malah turn it more than you want, right? So it becomes a real challenge, but it's definitely possible, okay? And this planetary gear set also allows for motor failure, and you still drive it manually with your effort, okay?
Would you like to learn in detail about more fascinating mechanisms?
Okay, that is it for steering. Next is what else do I have? Brakes. Okay. I don't know whether this has audio or not. I don't think it has audio. Okay, so let me just comment on it while it plays. So you got the front wheel brakes, you got the rear wheel brakes. The front wheel brakes are usually disc brakes, and the rear is drum brakes. The disc brakes are more efficient. We'll talk more about it when we get to brakes. Okay, you got the vacuum booster, because if you brake only on your own pedal effort, you will not exert enough force. Kalian ada nggak yang pernah mati mesin di tengah jalan lalu try to brake?
Pernah, Sir.
Apa yang terjadi?
Nggak bisa.
Susah, Sir.
Bisa.
Nggak bisa.
Tapi nggak kuat, ya kan?
Ya.
Because without the power brakes, your effort is only depend on your own legs. Even though there is Pascal's law, jadi the piston size still helps, but it's not that different. Maksudnya piston di master cylinder gedenya kira-kira segini. Piston di brakes kamu kira-kira gedenya segini. So it's slightly more, maybe 1:4, 1:5. But that's still nothing, right? And then you got your foot lever, ini mungkin 1:4. Jadi total 1:4 dikali 1:5, ya 1:10 lah. But 1:10 tuh nothing. What you can press with your leg is what? 10 kilograms. 10 kilograms kali 20 itu cuma 200 kilo. Sedangkan you need literally tons to clamp on that disc brake. Okay. So this vacuum booster uses the engine vacuum to assist you in braking. So, waktu kalian braking, you're actually controlling how much boost you're getting. It presses on the hydraulic lines, right? Hydraulic fluid. It's a hydraulic system. The hydraulic system is still used. Electric brakes are not. I mean, they gotta be huge in order to be powerful. So forget electric brakes. We'll stick with hydraulic brakes. In a drum brake, it's just a different mechanism. In a disc brake, you clamp on. Ini udah kayak rem di sepeda ya. Okay. You convert kinetic energy into heat. Right? So everything heats up. Setengah mv kuadrat jadi mc delta t. Right? So it raises temperature. Yeah, this is the brake drum, the drum brake. The drum brake pushes out instead of clamping the disc. You got brake shoe, ya, sepatu setengah lingkaran, nendang keluar. Okay, it is less efficient because the heat is kind of trapped inside, so you don't have a good heat dissipation. The brake shoe is trapped inside. It's not as efficient, tapi ditaruh di ban belakangnya karena ban belakang less braking. 70% of your braking is done in the front. On front engine cars, it's even more. It's probably 80%. Yeah. Okay. Braking, suspension.
Together. Sucks way. Let's get back to talking about one of the three fundamental components of suspensions in my third favorite season, spring. Now, there's a couple of types of springs that can be used. There's leaf springs, several layers of metal bound together to act as a single unit. And these are usually used on a lot of trucks. But they haven't been on a ton of US cars since '85. There's torsion bars. Here, one end of a bar is anchored to the vehicle frame and the other end is attached to wishbone. The wishbone acts like a lever that moves perpendicular to the torsion bar. When the wheel hits a bump, vertical motion's transferred to the wishbone, and then, through the levering action, to the torsion bar. The torsion bar then twists along its axis to provide the spring force. These are more common on European cars, and there's coil springs, basically a heavy-duty torsion bar coiled around on an axis. These are the most common. Anything above the springs and supported by them on the vehicle is sprung mass. Anything below the spring, between the springs and the road, like the wheels for example, is unsprung mass. Unsprung mass was my nickname in college, or it was until that fateful night 3 years ago in September. Spring stiffness affects how the sprung mass responds while the car is being driven. Loosely sprung cars such as luxury cars swallow bumps for a smooth ride, but they're prone to dive and squat during braking and acceleration. It can have body sway or roll during cornering. Tightly sprung cars, like sports cars, are less forgiving on bumpy roads, but they minimize body motion so they can be driven aggressively, even around corners. But you can't use just springs, you silly goose. Springs absorb energy, but they stink when it comes to dissipating it. That's why you need dampers. One common dampening structure is a shock absorber. Shock absorbers slow down and reduce the magnitude of vibratory motion by turning the kinetic energy of suspension movement into heat energy that can be dissipated through hydraulic fluid. A shock absorber's upper mount connects to the frame and the lower mount connects to the axle. In a twin tube design, the upper mount is connected to a piston rod, which is connected to a piston and sits in a tube filled with hydraulic fluid. Feels like I said that. The inner tube's known as the pressure tube, and the outer tube's known as the reserve tube. The reserve tube stores excess hydraulic fluid. When a wheel hits a bump in the road and causes the spring to coil and uncoil, energy of the spring is transferred to the shock absorber through the upper mount, down through the piston rod, and into the piston. Orifices perforate the piston and allow it to leak through as the piston moves up and down in the pressure tube. Because these orifices are relatively tiny, only a small amount of fluid under great pressure passes through. This slows down the piston, which in turn slows down the spring. Shock absorbers work in two cycles. The compression cycle, when the piston moves down, compressing the hydraulic fluid in the chamber below the piston, and the extension cycle, when the piston moves toward the top of the pressure tube, compressing the fluid in the chamber above the piston. All modern shock absorbers are velocity sensitive. The faster the suspension moves, the more resistance the shock absorber provides, so they can adjust to road conditions and control all the unwanted motion that can occur in a moving vehicle, including bounce, sway, I hate that guy, brake dive, and accelerating squat. Another common dampening structure is the strut. Basically, it's a shock absorber mounted inside a coil spring. Struts provide two jobs: dampening function like the shock absorbers, and structural support for the vehicle's suspension. They do a bit more than shock absorbers, which don't support vehicle weight. They only control the speed at which the weight is transferred in a car, not the weight itself. The Mac Daddy of struts is the McPherson strut, invented by Earl S. McPherson. No one knows what the S stands for except for Wikipedia, which says it stands for steel. Cool. The McPherson strut consists of a single control arm and a strut assembly, which allows tire and wheel to move upward and downward. Its design allows for a reduction in a number of parts, lowering unsprung mass as well as smooth driving comfort. These are pretty small, not too complicated, and not too expensive, so they're pretty common. They don't take up much space horizontally, so they're super common in front suspensions on the front-wheel drive vehicles. They do take up a lot of space vertically, though. Another common type of front independent suspension, the double wishbone suspension, or an A-arm, doesn't take up as much space vertically, but it's a horizontal hog. That one guy in that comment section. While there's several different possible configurations, this design typically uses two wishbone-shaped arms to balance the wheel. Each wishbone, which has two mounting positions to the frame and one at the wheel, has a shock absorber and a coil spring to absorb vibrations. Double wishbone suspensions allow for more control over the camber angle of the wheel, which describes the degree to which the wheel tilts in and out. They also help to minimize roll and sway, and they provide for a more consistent steering feel. That's why double wishbone suspension is so common on the front wheels of larger cars. Real quick, let's look at a couple of rear suspensions in a split-second picture of my belly button. These are usually a little simpler because you don't need to integrate the steering. For a dependent rear suspension, if a solid axle connects with the rear wheel.
Okay, that's a lot to swallow. Dia lumayan jayu sih. So the point of suspension, remember, is the three functions, right? Now, in order to accomplish this, let me go to my slide. I think I have some pictures. Okay. Keluar ya PowerPoint saya.
Keluar, Pak.
Okay. Okay. So a typical suspension that you see today is called a McPherson strut. Okay. A McPherson strut is you have the shock absorber in the middle and the spring coiled around it. Okay. Spring coil around it. So it's basically you have the body of the car, you have the spring, and you have the damper. Okay, so this is a mass spring damper system. Mass, spring, and damper. Okay, the damper is to get rid of the energy. The spring is to bounce it back to the original and to absorb energy. Also some, not much. Okay, if you have the spring without the damper, your car will be endlessly bouncing, right? The damper is there to kind of stop the bouncing. This is a second order system if you study it in applied math with Bu Yunita. Okay, now the rest of it, I don't think we need to watch a video. We're almost out of time. Let's see what else I have not covered. Transmission. These are the ratios. We'll talk more about it when we get to power transmission. The valve, right? Camshaft, timing, intake. You got the valves, intake, exhaust valves, mufflers, cooling systems. Basically, you run water lines along your engines and then and pass it through the radiator. Okay, so this is the cooling system. It's relatively simple, but you have some more piece to regulate the pressure. Here's your control unit, and this is a 1994 Honda Civic control unit. And you see you get that much wire. And this is mid-1990s technology. Okay, it's a typical engine wiring harness. This is just the engine, not to mention the airbags and every other accessories in your car. You know, the engine control unit controls more than just running the engine. Okay, it's also connected to accessories. For example, if you press on the throttle all the way 100%, it turns off your AC compressor. So basically, you get rid of all other overhead yang consume power and then put everything on your engine. So it does smart things like that, right? And siapa di sini by the way yang masih panasin mobil? Kalau sebelum jalan? Okay.
Saya, Pak.
These days, you don't have to. Okay. Welcome to the 20th century. They do have temperature controls. Jadi artinya waktu engine kalian masih dingin, it raised up the idle RPM. It also adjusts the air-fuel ratio. It adjusts the ignition timing. So it makes all kind of adjustments that needs to be adjusted waktu engine kamu masih dingin. So yeah, you don't want to drag race the car when it's cold. But other than that, you don't need to worry about it. Start and go, because they have temperature sensors. It senses your engine temperature, your oil temperature. Well, maybe not oil temperature unless it's a sports car, but also the air temperature. So it adjusts for everything. As long as you're starting off slowly, I mean, there is no problem of using your car when it's cold. These days, all the sensors are much more. We discussed steering, suspension, yep, tires. What you're buying when you buy tires, good tires, is basically you're buying material. Okay? Karena material tires itu yang paling efek, believe it or not. Bukan garis-garisnya. Garis-garisnya itu cuma cosmetics doang. It really makes very little difference. The most difference in a good tire versus a bad tire is a material. Okay? But there is always a trade-off. Kalau kalian mau tires yang quiet and comfortable, okay, it usually has less grip. Okay, tires yang not noisy itu biasanya lebih keras, tapi akibatnya less comfort dan it doesn't grip as well. Kalau kalian mau,
sir.
Kenapa?
Bukannya yang kembang apa sih alur ban itu pengaruh banyak ya sir buat gripnya?
Itu pengaruh buat jalur air, tapi maksud saya tuh, design A versus design B versus design C, it doesn't make that much difference, right? As long as you have the water channels, you're fine, right? The water channels is there to provide exit points for the water, but that's it, right? I mean, there is nothing much to it. In 4-season climates, ideally you need summer tires, you need winter tires, because when you get to winter time, the rubber really becomes hard and your traction goes away instantly. You have all-season tires, but again, if you use all-season tires, then you don't get the best traction in summer and you don't get the best traction in winter. But hey, it's cheap. You don't have to keep swapping tires. I have my summer tire and I have my winter tires. Tapi kalau winter tires kalian dipakai di summer, it'll be gone in a month because it's so soft. It's soft, so when it's cold, it's not as hard, right? Summer tires are there to withstand the heat and it grips very, very well. Very nice. We talk about brakes a bit. Electrical, yeah, you got the charging systems, battery and starting systems. You got all the accessories, right? These serpentine belts. We'll talk about belts. Okay. So let's conclude this introduction. Yeah. We'll talk a lot about shaft. That's the first part of our the first section of our course. We'll talk a lot about shaft and shaft failure, shaft support like bearings, okay? All kind of bearings and bushings. We'll talk about that because again, machineries are all about shaft turning. So shaft is really one of the most important elements in the machine systems. And then we'll talk about power transmissions, right? There are gears. There is a gear, there's a belt, and there's chain. What are the advantage and disadvantage of each? And then we'll talk about other components like springs, bolts and nuts, and brakes, right? So it really kind of the surrounding components of a machine, if you think about it. All right. Let's see, where is my syllabus?